Now let's consider this example. If you draw a distribution of these data in terms of x-axis, you can imagine the data distribution. Due to this separate group, kind of outliers, a linear relationship between x and y should compromise the big gap between these two clusters. When your data are not fitting to the normal distribution, like the distribution in terms of x-axis of this data, so something like this in this case, we can take the non-parametric alternative for the Pearson correlation analysis, and that is called Spearman rank order correlation, or simply Spearman correlation analysis. The Spearman correlation is less sensitive than the Pearson correlation to strong outliers, for instance like them, that are in the tails of both samples. That is because Spearman's correlation analysis limits the outlier to the value of its rank. When the data don't have outlier, or you can observe a linear relationship, doesn't matter whether the relationship is strong or like this weak, both Pearson and Spearman correlation analysis will result quite similar results. For instance, like here, both analyses have relatively smaller size of coefficients, but they are anyway very similar. But when your sample size is small, when your data are not fitting to the normal distribution, or when the data are measured in a hierarchical order, it is recommended to choose Spearman rank order correlation analysis. So Spearman rank order correlation analysis is used in order to perform a correlation analysis for non-parametric data. The effect size of Spearman correlation analysis is called rho and written with this Greek letter. It is a counterpart of the R in Pearson correlation analysis. And this rho indicates how strong the relationship between the two variables is. And rho also ranges between -1 and +1. When rho value equals to 1, this indicates a perfect rank order correlation. And to judge how strong it is based on the size of the rho, we can apply the same criteria like we do for the R. And here you are presented with the equation how to calculate the rho, but I think when you are already considering whether you should choose non-parametric alternative, then I think you already have installed your statistics software in your computer, because when you consider about Spearman's rho or Pearson's correlation analysis, I'm quite sure that you are at the level of expert researcher. So of course you can calculate this using Excel, but my recommendation is to use statistics software in order to avoid some mistake which can easily occur when you calculate it by hand. Previously, we have calculated the Pearson's correlation coefficients based on this data. Let's calculate the Spearman's correlation coefficient rho And let's compare how different it is from Pearson's correlation analysis. So let's compare the rho value with the R value. So we are now in SPSS, and here we can analyze both analysis, correlation analysis, by clicking same icon and between lightness and bitterness, and Pearson correlation analysis as well as Spearman correlation analysis. And let's run this. Okay, so here the first one, 상관계수, indicates Pearson's correlation analysis, and indeed it says here Pearson correlation and correlation coefficients, and as you remember it is like so. And here in Korean 비모수 상관, and it refers to the Spearman's rho, and the coefficients is a little bit in terms of their absolute value. It becomes a bit larger than this, but it's around 0.8, again 0.8. So in this case, the data has been typical for the parametric analysis, but although we have chosen the Spearman's rho for this analysis, actually we have obtained very similar result.